This is the second video on projectiles for physics students. So a projectile for me is when the object is fired at an angle with a particular velocity. So the velocity or the speed is 15. Speed is 15 and the angle is 50. And then it will follow the path as shown here. So that for me is a projectile. A couple of things to remember. Most importantly is that you separate the motion into a horizontal motion and a vertical motion. And we assess it based on what happens horizontally and what happens vertically. Vertically, it's very similar to that. So like so. So that's the vertical effect. And then horizontally is if it was fired straight across. So we're saying that that motion there has a vertical component. In other words, it goes from a particular velocity, it rises to a maximum height where its vertical velocity is equal to 0, and then it accelerates downwards. So there's only an acceleration vertically. It decelerates on the way up, stops, and accelerates on the way down. So that's number one. The second component is the horizontal component. And horizontally, there's no forces acting on it horizontally. So there's no acceleration horizontally, in which case it travels just with constant velocity. That might be a bit hard to get your head around, but just remember, no forces horizontally, so no acceleration horizontally, just constant velocity. Let's have a look at it in more detail or have a look at it again. So there's your projectile. It's fired with a velocity of v at an angle of theta to the horizontal. And what we do is we break it up into a horizontal component. The horizontal component moves at constant velocity. And we break it up into a vertical component. And the vertical component decelerates on the way up with a is equal to minus 9.8. It then stops at the maximum height and it accelerates on the way down with acceleration plus 9.8. So it's the two types of linear motion you've dealt with, just added together in some unusual way. All right, so a couple of things. So if it's horizontal velocity, because the acceleration is equal to 0, then you just use speed is distance over time horizontally. That's the only formula you need. Or velocity is displacement over time if you're using the vector form of those. And then for vertically is just like the questions I did in the previous video. We use the constant acceleration formula on log tables page 50. Okay, let's have a look at an example. So in this case, we're told that a particle is fired horizontally. It travels the dotted path there and lands somewhere beneath the cliff. And the cliff is 22 meters high, 35 meters, lands 35 meters away from where it was projected. Now what we know for sure is the time taken for it to drop the 22 meters is the same as the time taken for it to travel horizontally 35 meters. And that's what I'm going to rely on. So let's look at it horizontally first, and we apply speed as distance over time. That means when I fill in the distance or the displacement of 35, I don't know the velocity, I don't know the time, but I can rewrite it to get the time as 35 over the velocity. I need that because I know the time taken for the drop 22 is the same as that time in the formula on the right hand side. So then let's look at it vertically. I'm given a displacement. I have stuff related to times, and my u value there will be the v value in the horizontal formula. So I know acceleration is downwards. It's 9.8 downwards. I know the displacement is downwards. It's 22 downwards. So I'm going to say downwards is positive, in which case I get 22 is equal to that. Now, when you sub the t equals 35 over v in there, you'll get your answer. Now, I suppose one question there would have arisen. I did make a mistake when I was calling this out. In the s is ut plus a half rt squared formula, we're looking at the motion of the particle vertically. And in this case, the velocity is horizontal, so the projection velocity or the initial velocity vertically is 0, which is why I've got a 0 there in the second part, which is 22 equals 0 plus 4.9 t squared. No vertical velocity. All right, you can work that out there. Okay, so you've got the 2 times, leave 22.1 equal to 35 over v, and you get that. Okay, second idea, maximum height. The vertical velocity is equal to 0. We came across that already. And then there's a thing called the range, which is the maximum horizontal displacement. For the range, what we would have to do is let the maximum height equal to 0 and get the times when the height is equal to 0. You'd get a quadratic. One time would be equal to 0. That would mean that its height is 0 at the start. The non-zero time would be the time taken for the particle to fly through the air and land. And then once you have that time, you'd fill that time into the horizontal displacement is equal to velocity by time formula. And there's how to get the range. Okay, I'll pause it here and I'll do a third video in a moment.